Hello again from the workshop. So today, I'm not sure what to title this episode yet, but we're going to be doing another bit of unboxing, unbagging. I have this nice collection here from Model Engineer's Laser. So we're going to have a look at that and see what we've got and see how it fits into things. So let's start with that and we'll see where we go from there. So here we are again, unbagging our first consignment from Model Engineer's Laser. Now, laser cutting is quite a recent innovation in model engineering. Well, maybe not that recent, but certainly the accessibility of laser cutting for small quantities and for very special things that we do has become very much more available through Model Engineer's Laser. They've been going for a few years and changed hands once, but their aim is to provide a service for model engineering, not just selling product, and they have helped tremendously in doing this by taking the drawings that I had from Clarkson's and doing the necessary CAD to put them on a laser cutting machine. And surprisingly, the cost of laser cutting is very reasonable. You wouldn't think so, but to be honest, when you are looking to cut this stuff yourself, then the amount of material you're going to have and the amount of wastage you're going to have is very, very significant. I'd also say that Model Engineer's Laser do a very good job of packing stuff to make it very difficult to get into. So, alright, first layer off. Remember pass the parcel when you were a kid? Wow, what have we got here? So, okay, one bag of links. It says temper the material by raising to 400 centigrade for a minute and allow it to cool naturally. Using a lynching machine or polywheel and an angle grinder, but not grinding disc is too harsh. Use diamond file as normal files will not be hard enough. Oh dear. Alright, so we've got a task to do with prepping this. And here are a set of rods. Oops. So, I think what we're going to do first is we're going to get the drawings out and we're going to compare the parts to the drawings and make up any labelling that we think necessary to make sure we don't forget what's what. So we'll start by digging out the appropriate drawings from the drawing set and the magic book. Keep notes of everything and keep a record of what you're doing. We're looking for valve gear drawings, cylinders and valve gear. That's the one. Okay, here we have valve gear drawings, and let's just see what's what. So these should be coupling rods. And we've got centers marked on them. This, I think, is the inside rod, inside coupling rod that's teed off at the end. We need to come back to that one. Now, that's also a coupling rod. I bought 3 because what I'm a bit nervous about is doing the fluting. I've never done that before. Also, though it hardly looks like it, there's a fish belly on these rods. Very slight, very marginal, but it's there nonetheless. So basically, we'll have to lose quite a lot of thickness because, yeah, right. So the thickest part of the rod, if you're cutting this out of sheet, start with the thickest part. The thickest part of the rod is the coupling onto the trailing wheel. This goes in a fork on the in the con rod. So again, the outside con rods have not been drawn correctly. I have subsequently drawn them and have sent the drawings to Model Engineers Laser for them to cut to how they should be. What you can see there, that's the rod, and you can see maybe just at that end, that's forked at that end. I went to see Murray Shah the other day, and it's quite interesting how that all goes together, because it's nothing like what's on here, and it's also nothing like standard construction. It's an American, is it Woodward patent idea, and the only locomotive in Britain that was so fitted. So the interesting part of that is how that bearing arrangement there works. On the real locomotive, what you've got is you've got the crank pin, you've got a bronze sleeve on the crank pin, and then you've got a steel sleeve which sits over that, and that has 3 steps in it that correspond to these 3 diameters here. That's a steel thing. This rod, which is these, must have a bronze in here that rides on that sleeve, because the sleeve is steel. So you've got bronze, steel, bronze. That pin goes through there, steel connections on that, riding on a bronze sleeve. So that all needs drawing up in a bit more detail and figuring out how I'm going to do it, because we need to get 3 diameters on that piece that are all just marginally different, that all sit variously into the things it fits. So that bit is on the list now. Let's see what else we have here. Okay, I don't see that on this drawing, but I suspect that's going to be part of the lifting link arrangement, so we'll leave that to the side just now. The 2 drop links next. Are they on this bit of the drawing? Okay, not entirely sure what those are. These are also drop links. Those sit that way somehow. Those are oil pockets. Those are also not obvious from this drawing, so I have to do some more research and figure out what they're meant for. The last 2 bits in this batch are these bits. Wow, So as we went before, that's another £100 more or less, £94 worth of parts for this project. Looks like that is going to be something that happens quite a lot. £100 a go. Hold on, it doesn't fit there. And that doesn't fit there either. Oh, how interesting. All right, so that is supposed to be that part. So the length of that should be 7:25, 30 seconds. Less a bit more than half an inch. One plus 32 so that's 8 and 9 30 seconds. That should be. Well, on the drawing I can take that off quite satisfactorily. All right, so there's cleaning up, dealing with edges, drilling, and with these parts quite a lot of machining to get these down to the right sizes. Ditto this thing. That thing is there. Quite a lot of machining to do to get those to size. All right, well, that's what's arrived today. Definitely some cogitation required. Let me think what I'm going to do next, and I will come back in a wee while. Okay, so a little bit of progress here. Tactics, bags with the name of the parts on them, where I've got bags the right size. This is wrong. It's too long. It actually matches the length of the outside coupling rod, but that's incorrect. Connecting rod, that's incorrect. It should be for here. So it's too long. I can still use it. I can still cut off here and make a new end arrangement like this, or not even quite like that actually, but that's failure. So I basically tried to clean this one up on the linisher a bit. It said you go on the linisher to try and get the hardness off. I've not quite got through all of the laser marks, so I'm probably not down far enough yet, and I gave that a quick spin to see what it looked like. The important thing though is, remember this is set to the axle spacing, and these are marked up dead correct. So that is all good news. That is ready to go. Not for today. I think today's task is going to be working on the frames and trying to figure out how to set them up most effectively in the mill in order to start drilling holes in them to fit the stuff we made before. So this is all going in the box, and I'll see you in a wee while. So today's activity has been rather boring. what I've been doing is trying to figure out a way to get this chassis, this frame, onto the mill table in a way that's secure and allows me to drill the holes that I need to do in this instance for the pump, to redo this because this is all wrong. That needs considerable thinking about how I'm going to fix that. So as there's a lot to it, I've had to jack it up on wedges. Then I didn't have anything that would hold it down, so I had to make then 2 hold down bars, which are bits of 20mm mild steel with 10mm holes. Really boring things, so again I didn't bother recording that for your entertainment. Too boring. So what I've done at the moment is I've now set the pump cross frame in place as best I can, and I've been looking to see how the drill pattern is compared to what it should be. And to be honest, it's not correct, and it's not that regular, so I'm going to have to basically position find each hole and then drill it through. So the holes are clearance for 4BA, and the drawing calls out 4BA countersunk. Whether I'm going to do that or not, I don't know. I'm minded not to do that and just use small hex head, because I don't think those heads are going to get in the way of anything. But what I will do is, actually no, they won't do, because the brake blocks go here. So all that's going to be coming forward of that is stuff in this plane, which is the the con rod. So I'm pretty safe to just drill that where it is, and that's okay, and put hex heads on it. I left you with the clamping this thing in place. That has been a bit of a monstrosity, really. As I said, I've had some doubts about this casting already, and the thing I've found now, which I also wasn't clear of from the drawings, was the fact that the crossbars here actually go through that opening. So I need to get this back on the mill and open that out to 5/8. But that is going to impinge on the pump flanges, so I'm not entirely sure quite how that is going to work out, but that's what it is. So at the moment, I've dimensioned this as close as I can from this point, because that's the only place there's any reasonable dimension from, and that is to that line of fixings. So I've followed that, and I've tried to measure this off of this flange as far as possible, checking with what the crossbars I've already got. So it's slide bars, I keep saying that, sorry about that. So that is now in on this side. Okay, so I've flipped the frame over now. I've packed this end of it so that it's level as to that using a digital level meter. I've lined up this with the beds as visually as close as I can do it. There seems to be no point in getting any better than that. I'm not sure how we would do it other than tramming it in, but the problem with that is that I'm not 100% certain how square the frame is. So what I'm going to do now is measure out these 4 holes with the DRO, then I'm going to drill them, start bolting, then I can get rid of that clamp and drill the other set of holes. So this is going to be a bit long, drawn out. I saved you looking at the other side, but I thought for completeness I'd show some drilling action here so that you've got an idea of what goes on. So first hole, there's 0, 0. Second hole, make sure that is square in. What I'm looking for is looking for any movement of the drill if it's hitting the sides, which it's not. So that is Y is 0.443. Next one. one seems to be, yeah, that seems to be on the X all right. That looks visually central, that's 8925. That looks good there. So while I'm here, I'll start drilling here and go down and see what I can get. So I'm running this at quite a slow, oh no, I've got to do the depth. So let's get a bit of shim. Iron Brew. Best provider of shim there is. So set that on there. Zero my mini DRO on the side there, which you can't quite see. Yeah, 5.5 thou basically. So I need to add 5 thou onto my depth. I want to get, what did I do last time? .365 it was. That just takes me through the casting. So next position is 8925. Alright, so this arm of the casting is somewhat thinner than the other arm, it would seem. They look the same, but that one is definitely going through. Next one is 443. The final is 00. Okay, so we're going to just pull it out and put some bolts in here. It's as far out as I can get it. That's annoying. That's really annoying. How am I going to do that? Okay, I'll just take it out on the X, see if I can get clear that way. Okay, how's that feel? This is a taper. Get this started. And I've got bottoming tap to follow through with. Okay. Actually, that's a number 2. The taper is too tapered to get into there. So there's another nice old tool. Boot sales, auto jumbles, and the like are really good for finding good old tools. Hey, look at this compared to what you buy these days. Let's try and find a modern one. Yeah, I mean, quality difference. This is a bigger one. But just the whole way the thing is made and how it feels on the hands, totally different. Give me an old tool anytime. Oops, make sure it starts in the thread. You don't want to mess the thread up at this point. So, again, going into cast iron, it's really nice. Always works. That's it. Doesn't usually happen with this. Yeah, adding to the shopping list for Model Engineer, Midlands Model Engineering Exhibition is specific nuts and bolts. In the meantime, what I've got available, that's the right length, is slotted, which is obviously not going to look good if it's left there. So the drawings call for this to be a 4BA countersunk. If you look on the chassis, you see that? Yeah, those are very small, I presume BA Allen key countersunk in there. So I could do that, or I could just put hex head in here because the heads are not going to get in the way of anything else. Let's pull it out and do the next one. Start with the taper tap. Bit of my new puddle of metalworking fluid. Now, normally I would use a tap guide in the drill or in the mill to help start this, but it's not the height to do that. The frames are too high and the chuck is too deep, so we're trusting the taps, the taper taps, to find their own way in. Very light with this until it finds the thread. The last thing you want to do is to start cutting another thread in here. That would really mess the thing up. Also be careful not to go too hard, because there's also a risk that you will strip the entire thread, which is obviously not what's indicated. Keeping the tap clean and ever so slightly lubricated is a good thing to do. Ah, well, that is what I didn't want to have happen. That is really annoying, and it just suddenly went. There was no sense of warning on that. Okay, I'll come back to that later, but what I need to do next is to lift the, pull the clamp off so we can actually drill the other holes. abusive tool coming up. Oops. Really shouldn't do that, but I don't have a convenient Tommy bar. Right, that is stuck out a bit, so hopefully that's going to come out relatively straightforwardly. I'm not sure I've got another 4BA bottoming tap, which is also a bit annoying because that stops progress on that. Anyway, let's go back now to drilling. So what do we got here? X is 28, Y is 0012. Let's fire away with this one. So just in case it isn't obvious, we are putting a tapping size drill through a clearance size hole. It was only a few thou. So, tapping of these we've got to do now. You'll be careful when you're clamping onto a table like this, because if you put too much torque on these, what can happen is you can actually bend that. Not significantly, but enough to make it much stiffer to operate, which may or may not be a problem depending. Right, so now these holes go all the way through, so we don't actually need a bottoming tap. If I can drive that all the way through, we will be good. Yeah, the other handy thing we've got here is we're not freehand tapping from the top of the hole. We have the clearance hole as guidance for the tap as well, which helps. The 4BA bottoming tap on the shopping list for model engineer exhibition, or maybe not. If I can find HS, this is a high-speed steel tap. I think that was a carbon steel tap. High-speed steel is a little bit more flexible. It's running beautifully. Okay, next one. Clean the tap. Touch of metalworking fluid. These aren't the right bolts, whatever, but it's good just to make sure everything is lined up and fitting properly. So these are 4BA with a 5BA head, nut spinner, horrible cheap plastic thing it was. The handle broke, so I made a nice new brass one. It's a much nicer tool to use, got more heft to it, and again feels good in the hand. I think it's important that tools feel good in the hand. The next job I want to do is to look at this. I fixed the other side. What I've decided to do is put 4 fixings along the top as per the drawing, 1 fixing in each side as per the drawing, and rescue 2 fixings at the bottom. There's a problem with this in that these pieces that I made earlier, which you might remember, according to the drawing, sit right tight to that. So there are some issues with clearances, and definitely a necessity to make fixings that go on that line fully countersunk so this sits on top. The actual drilling pattern for this shows the fixings going in between the vertical fixings here, so there'll be one there and one there. That's not that way up, that's that way up. Again, if you remember, the key dimensions on this part were the slide bars there and the foot plate there. Now we've got references for the foot plate, and what I'm thinking is that before I fix this, I'm actually going to make this set of slide bars. I just found the materials for that, and that may be a project in a episode or so's time. So I'm going to stop here and start looking at this. I might come back to this in a while. Right, I've finished operations in the mill for just now. What I've done, drilled all of this, broke the tap, and that's why it's coming out. I've basically re-drilled this to 4BA from the 6BA that it was. I've also redone the pattern so it's closer to what's on the drawing. Some of the holes are almost drilled at random. It's not perfect to the drawing, but it's more regular and the positions are about right. I've got 4 along the top, 4 along the bottom, and that should be plenty to hold it all together. So next job really is to get this out, and that's going to be a little bit tricky because of the tap. I don't want to break off any more of the tap because that makes it more difficult to get out. So what I'm going to have to do is take all the bolts out of this, all the bolts out of this, top and bottom, then probably take out these 3 to give us some flexibility. Then I'm going to try and jack the frame apart and see if we can get this out and then deal with the broken tap. So it's coming out.